As of my last update in August 2023, there are no credible predictions or evidence indicating that an asteroid will definitively strike the Earth in 2038. Such claims often stem from misinterpretations of scientific data or are fueled by sensationalist media reports. To understand this topic comprehensively, we need to explore several aspects. 1. Asteroid tracking and prediction. NASA and other space agencies. Organizations like NASA, the European Space Agency, ESA, and other international space agencies actively track near-Earth objects, NEOs. They use sophisticated telescopes and radar systems to monitor and predict the trajectories of these objects. Near-Earth Objects Program, NASA's Near-Earth Object Observations (NEO) program, also known as Space Guard, is dedicated to discovering, characterizing, and computing the trajectories of NEOs to assess their potential hazard to Earth. These efforts are crucial in providing early warning and mitigating any potential threats. Current predictions. According to the available data, no asteroid has been identified with a significant probability of impacting Earth in 2038. Predictions about asteroid impacts are based on extensive observations and calculations that take into account gravitational influences from the Sun, planets, and other objects. 2. Historical context and public perception. Historical impacts. The Earth has been impacted by asteroids and comets throughout its history, with notable events such as the Chicxulub impact, which is linked to the extinction of the dinosaurs around 66 million years ago. However, such events are extremely rare. Public concerns and misconceptions. Public anxiety about asteroid impacts has been amplified by media portrayals and misinformation. Movies, books, and sensationalist articles often exaggerate the risks, leading to unnecessary fear. 3. Scientific analysis of specific asteroids. Asteroid 99942 Apophis. One of the most talked about asteroids in recent years is Apophis, which was initially thought to have a slight chance of impacting Earth in 2029 or 2036. However, subsequent observations have effectively ruled out these possibilities, demonstrating the importance of ongoing tracking and analysis. Other monitored asteroids. There are many other asteroids that are tracked and analyzed for potential future impacts. Each one is given a probability rating based on its size, trajectory, and potential for collision. 4. Mitigation strategies. Deflection missions. Space agencies have been researching and developing methods to potentially deflect an asteroid on a collision course with Earth. Projects like NASA's Double Asteroid Redirection Test, DART, aim to test these deflection techniques. Global cooperation. Addressing the threat of asteroid impacts is a global concern, and there are ongoing efforts to coordinate international response strategies, including information sharing and joint mission planning. 5. Recent developments and research. Advancements in technology. Improvements in telescopic technology, data analysis, and computational models have enhanced our ability to detect and predict the movements of NEOs. Future missions. Upcoming missions and projects will further our understanding of asteroids and enhance our preparedness. For example, the ESA's Hera mission will follow up on NASA's DART mission to study the aftermath of an asteroid deflection attempt. 6. Asteroid flybys. Frequent events. It's common for asteroids to pass close to Earth without posing any threat. These flybys are often misinterpreted or exaggerated as impending impacts. Risk assessment. Scientists continuously assess the risk of these objects using a variety of methods, including optical and radar observations, to determine their size, composition, and exact trajectories. 7. Public communication and education. Informing the public. Accurate and clear communication from scientific bodies is essential to prevent panic and misinformation. Efforts are made to educate the public about the realities of asteroid threats and the measures in place to address them. Combating misinformation. It's important to critically evaluate sources of information and rely on credible scientific organizations for updates on potential asteroid threats. Asteroid tracking and prediction. Asteroid tracking and prediction involve a combination of observational astronomy, orbital mechanics, and computational models. Telescopes equipped with sensitive cameras and radar systems scan the sky, identifying objects that move against the backdrop of stars. Once an object is detected, its position and movement are recorded over time to calculate its orbit. This process is repeated with various telescopes worldwide to refine the data. NASA and other space agencies. NASA, through its Near-Earth Object Observations program, uses a network of ground-based and space-based telescopes to detect and track NEOs. The Jet Propulsion Laboratory, JPL, in California manages the Center for Near-Earth Object Studies, CNEOS, which calculates high-precision orbits for NEOs and predicts their future positions. The ESA has a similar program, the Space Situational Awareness, SSA, program, which monitors space hazards including NEOs. Near-Earth Objects Program. The SpaceGuard program was initiated in the 1990s following recommendations from several scientific bodies concerned with the potential hazard posed by NEOs. This program has significantly improved our ability to detect and track asteroids. One of its primary goals is to identify at least 90% of NEOs larger than 140 meters, as these could cause significant regional damage in the event of an impact. Current predictions. As of the latest observations, no known asteroid poses a significant risk of impacting Earth in 2038. Predictions are made using the Sentry Impact Risk Table maintained by NASA's CNEOS, which lists potential future Earth impact events. Each listed object is continuously monitored and reevaluated as more data becomes available. Historical context and public perception. The history of asteroid impacts on Earth is a subject of scientific study and public fascination. While the Chicxulub impact is the most famous, smaller impacts have also caused significant damage. For example, the Tunguska event in 1908 flattened an estimated 80 million trees over an area of 2,150 square kilometers in Siberia. Public perception of asteroid threats is often shaped by these dramatic historical events, despite their rarity. Public concerns and misconceptions. Misinterpretations of scientific data and sensationalist reporting can lead to public misconceptions. It is crucial to differentiate between credible scientific assessments and exaggerated claims. For instance, initial reports about Apophis led to widespread concern, but further observations clarified that it poses no threat in the near future. Scientific analysis of specific asteroids. Asteroid 99942 Apophis is a prime example of how our understanding of asteroid threats evolves. Discovered in 2004, initial calculations suggested a small chance of impact in 2029. However, further observations ruled out this possibility, demonstrating the importance of continuous monitoring. Other monitored asteroids. Many other asteroids are monitored for potential future impacts. Each one is assessed based on its size, composition, and trajectory. The Torino scale is used to categorize the impact hazard of NEOs, ranging from 0, no risk, to 10, certain collision with global catastrophic effects.